In this episode of Improving RAG Applications, I'm excited to invite Joe Burgum, a distinguished engineer at Vespa AI, to talk about the importance of building custom evaluations for RAG applications. He explains why off-the-shelf models and academic benchmarks might not generalize to your specific use cases, and provides a step-by-step guide on creating personalized relevancy datasets.
To get some feeling about some method or technique, the way you can do this is that you're building your own relevancy dataset.
He also answers a question that's been on everyone's mind. Can we actually train language models as a judge?
We can actually calibrate on using a large language model as a judge and align that prompt with the human preference that we find from the golden set and the human evaluation.
He also mentions the often missing baseline.
VM25 is actually a pretty solid baseline. It also avoids the fixed vocabularies of transformer models because they cannot learn representations of just if you're adding random words, like a product or a zip code. My name is Joe Burgum, and I work at Vespa AI as a distinguished engineer. I actually been working on Vespa and with the Vespa team since 2007. As you can see, I'm quite old and gray, not like you youngsters. I've been doing this for some time. And I'm gonna talk a little about building evals for information retrieval. Like, I love the title of your course, Jason, Systematically Improving RAG. And in this talk, about how we can go about building evals for the R step. So I guess I'll just jump right into it. You can drop messages. I will have plenty of time actually, since Benjamin is not joining. So I'll leave plenty of room to ask any questions you like. I have a lot of knowledge about both dense retrieval, vector and multi-vector, Beam25. I might throw in a hot take as well. So keep a good size chunk for questions on basically anything. So so this talk is building evals. Yeah, I'm a distinguished engineer. In my spare time, I post memes to Twitter. So in this talk, I'll talk a little bit about retrieving information into the large language model prompt or the vision large language model, the R in RAG, and evaluations, and how you can go about building your own evaluations so that you can impress your CTO, or maybe you are even the CTO. And RAG, of course, most of you are familiar with this. You threaten the model to perform some action, and we want to use retrieval system to retrieve up-to-date context so that we can stuff into the prompt. The prompt context limits are now longer, but still we can only fit about 8 megabytes of text still, like with Gemini Flash and Gemini Pro, again, 1 million context length. So it's about 8 megabytes of text. So I still think that retrieval is useful. In this example, it's not a classical RAG, but you can use retrieval to find context-sensitive examples. If, for example, I'm doing classification, I'm actually quite excited about that. I wrote a blog post about that a few days ago, or a few weeks ago, but you use retrieval as a technique for finding context-sensitive examples when you're doing in-context learning. But most of our excited about RAG is in the context of question answering, where you're using some retrieval system to retrieve information and then perform question answering. And that was also the original concept of RAG, introduced, I think, around 2020, 2021. But in any case, these techniques that I'll talk about later and evaluations is really independent of what you're using your RAG pipeline for. Reference architecture, people talk about vector databases, search engines, etc., etc. But the kind of overall is that you have some kind of, or you have some language models, some prompting, maybe you have some routing. In this case, it will be like high level. I won't go into selling Chroma or selling Vespa or selling Elasticsearch or whatnot. So you can pretty much use any of those for a retrieval system, right? So when I talk about retrieval system, could mean anything or any type of method. And these systems produce some output, and each of the steps, you can evaluate each of the steps independently or the full chain. Yeah, so there's interesting. And unfortunately, there's a lot of complexity involved in RAG. And every day there's a new thread on Twitter, like new model, new large language model, this capabilities, this weird trick, some advanced techniques you need to learn about, new 7 billion embedding model, So there's a lot of stuff going on, and you might be tempted to try this and that, and maybe change the vector base, maybe use PG vector or use Pinecoin or LanceDB or whatnot. So there are a lot of hypes, DevRels going around trying to sell different techniques. So it's a lot of things that is going on. But the R component in RAG is really about information retrieval. And information retrieval is basically the process of obtaining some relevant information based on the information need expressed into a textual query or a question. And this is like a huge field of research that has been basically occupying some of the brightest minds in computer science for decades. Like I'm thinking like Google, Facebook, Bing, Microsoft, both in search systems, but also in recommender system, right? So there are a lot of people that has put a lot of years and effort into this entirely new field. And when we have this kind of retrieval system, and if we think about the slide that I had earlier on, like any kind of system, like if it's a file, if it's NumPy, doesn't matter. You have some input query, and this retrieval system might do multiple different steps, query planning, query embeddings, whatnot. We abstract that away. In essence, you input a query to this system and you get back a ranked list of documents. That's the kind of core. And then we can look at the documents that we get back from this system for a given query. And then we can basically judge these. Are they the documents that are retrieved? Are they relevant for the query? And then typically we could have like binary judgments saying that, oh, is it relevant or irrelevant? Or we can have some kind of graded labeling schema where you can say that, oh, this passage is actually, or document is actually very relevant for the question. It fully answers the questions, or it's slightly relevant, or maybe it's irrelevant, or it's so bad that my boss will fire me. So they're like, you can have this type of graded systems, graded evaluation. I mean, Han, he put out this tweet that got my interest. I think it was actually yesterday. And grading relevance is not trivial, right? So Google has their search engine quality evaluation guidelines. This is a PDF with 100 pages that they give out to the human evaluators that are evaluating their search results, going into what is relevance, how should you judge the results, and judge them on this scale and so forth. It's not that trivial actually and also relevance is subjective, because if you're looking at the query log and someone searched for Apple, and then you're asked to judge a set of results coming back from our retrieval engine, we don't actually know what that given user was looking for, right? Because it could mean the fruit, it could mean the company, right? And when that user is getting back information from the retrieval engine and he meant the fruit, but he got back to the company, he might be judging the results as irrelevant, right? So relevancy is subjective. So there's very hard to have like one ground truth. And typically when they're editing these systems, if you have two humans, they might disagree or over the relevancy of a given query, right? And if you have that kind of graded or relevancy judgments for query and document pairs, we can run some evaluations to say something about how good the retrieval system is at retrieving relevant information for a given query. And to do that in academia, there are a set of information retrieval data sets. TREC conferences be going for, 20 years, spanning decades with various interests from news search to search at large scale and so forth. So multiple different tasks. MS Marco passage and document ranking is a large relevancy data set that was released by Bing. I think it was like around 2018, 2019. And it's one of the biggest data set that is also used to both evaluate methods, but also use this data for training retrieval models to learn how to retrieve and rank. The beer benchmark is also very popular to edit models, and the focus there is to take a given model or retrieval model, be it embedding or be it BM25 or BM42, doesn't matter. You can evaluate in a zero-shot manner. And by zero-shot, I'm meaning that you haven't been exposed to any of the training data in those collections. You're basically taking your model, indexing the documents, and then evaluating the system in a zero-shot. And then there's a set of ranking metrics, which tries to measure how well this retrieval system And typically we have recall at K. So we have a depth of the ranking list that we're looking at. So K equals 10 would be to only consider the 10 first documents or text and passages or whatnot returned by the retrieval system. And I typically say that, okay, recall at K actually measures, are you getting all the relevant results that you have in the collection? But in a large collection, you might not know all of the documents that are relevant for a query. So recall at K is typically there's some level of discussion around recall at K, some what it means and so forth. So, but it essentially in information retrieval, it's about if you have a set of annotated documents that are at a certain relevance label, you're measuring if the system is able to retrieve all those. Precision at K is about removing irrelevant results so that you're presenting nothing but relevant results in the first K positions. Then G is a complex metric, more complex. It takes into account the graded relevancy labels. So if we use a graded schema where you say irrelevant, semi-relevant, or highly relevant, NDCG tries to measure that. So if you're placing a very relevant result in position 1, you get a perfect score. And if you're placing the perfect result further down, you get a decay. And also you have reciprocal rank, and also maybe the most common one, which is LGTBM, which is looks good to me. And we want to kind of move away from that. And in the industry, of course, it's not only about relevancy, but there's also metrics and feedback like click, dwell time, e-commerce. It will be like add to chart. Of course, e-commerce revenue is important. And in those systems, typically multiple objectives. So you want to optimize relevancy, but at the same time, you might want to also optimize revenue or time spent on your site and so forth. And importantly, when you are looking at M or beer or these kind of benchmarks, each of the queries are weighted with the same weight. So that means it doesn't take into account the frequency of the queries. So in your system, you might have some queries that are more popular than others, right? So typically these follows like a 80-20 distribution, where just a few 20% of the unique queries are maybe 80% of the total load. So when you're sampling systems and building evals, you should take that into account as well. And of course, what your CEO is likely to search for.
Hey, are your RAG applications falling short despite using the latest frameworks and models? You're not alone. I'm Jason Liu, and I've helped a dozen companies improve their AI applications. I've developed a systematic approach that delivers results. If you want to check it out, join my free 6-week email course and learn the techniques I use in my own consulting practice. That way, you can stop guessing at what works and measure what matters. Just check out improvingrag.com.
So to try to do better than looks good to me, the dirty secret that they've been hiding from you is to try to measure. But in order to measure, you should try to build your own evaluation data set. And that's the main portion of my talk. And also when we're looking at Twitter hype or MTab or what have you, it doesn't necessarily generalize to your particular use case, right? I know a lot of you are building RAG in different contexts. Finance, might be shopping, it might be in academic sense. It's not so likely that the MTab score translates directly to your domain, right? So to get some feeling about some method or technique, the way you can do this is that you're building your own relevancy data set. The motivation is that, as I said, those models that are trained on different types of data might not generalize to you, your queries, or your documents, and off-the-shelf models might also not generalize to your case. And typically what we see, at least over the last year, is that many of these models are being trained in a way that they are performing well on the MTab, the massive text embedding benchmark, or BEER, meaning that when you apply it to your specific use case, they might not perform so well. And if we have this kind of evaluation data set, this allows us to do kind of quicker iteration. If we want to change some parameter, if we want to change embedding, or if we want to change the way we're doing retrieval, if we want to add a re-ranking to the mix, if we want to do a query, it will allow you to do a quicker evaluation and actually get feedback from this relevancy evaluation data that you built. And this step actually has 3 simple steps. And the first one is the one where you have to come up with queries and run these queries against a retrieval system and get them. You could do it, or you can have a domain expert for what you're building for, the use case you're building for. If you're building for healthcare or health information, things like that, you might want to have a domain expert. And after we've done that, we can actually calibrate and using a large language model as a judge and align that prompt with the human preference that we find from the golden set and the human evaluation. And then once we have that, we can actually start using the kind of prompt to create more data and build a larger data set. So I'll go more into details on these three steps. Yeah, so this work or my talk is not come out of thin air. There's been a lot of research over the last 2 years on this and used large language models as a judge for relevancy. And most of the research finds that the frontier models can actually accurately predict the social preferences. But we need still to collaborate that with our domain expert in our data. So we cannot entirely trust that if we just let the large language model with this given prompt that it will evaluate it perfectly with our golden set. So we need the first step and the second step to kind of calibrate things and align it with our human preferences. And once we have that, it allows us to expand this kind of training data and expand the training set. And finally, we can also use this to further improve for fine tuning. I know people are talking about fine tuning models or re-rankers. So it allows not only edit the system, but also to improve the system. And Umbrella is also very recent work. The Umbrella paper and the method there that they're proposing, that's going to be used actually to evaluate ongoing track, the Retrieval conference topic, which is about RAG, actually. That's going to be exciting to see what kind of techniques will actually be working well. I mean, in this, and they will actually use the large language models as a judge. But how do you get about and start bootstrapping this relevancy data set? So this relevancy data set consists of a query and a document and a relevancy label. So it's quite simple. It's a triple. And if you already have real traffic, you can sample queries from real production traffic, preferably with them starting with head traffic. So most popular queries or the middle. At least that's a good starting point. Don't have traffic, you can ask a large language model to generate queries for your content. So you take all of the content and generate questions. But it's also not so easy to get that right. So preferred traffic if you actually have traffic. And this process doesn't need to be fancy. You don't need any fancy tools for this, right? You can just jump this into a simple tab separated file, right? So, and you have to choose if you have grades. If you want to grade the results, I find that because I'm sure relevancy is on the grade and Google and most of the people are using that. So I think that's great. You can also kind of try to write down your thoughts about how to evaluate the relevancy. The PDF that I linked to earlier with Google guidelines, because those kind of guidelines you can also add to the prompt when you are instructing the large language models to evaluate the relevancy for you. Once you have that data, you can start analyzing and to have your kind of golden truth data set with the relevancy label for each of these query and document pairs. Then you can ask the large language model to also grade it using the kind of system level instructions that I previously shown. And then you can see if they align. So this is a confusion matrix, and it's called that because all of us get confused when they see it. Take a rundown of it. So human label on the left of the y-axis. So we have 0, 1, 2, right? So this is the assignment by the human. And on the x-axis, we have GPT-4 label. So if you see on the upper left, there are 10 query document pairs where there is agreement between the human label and the GPT-4 label. And there is one item up to the upper right where the human has assigned that this document is irrelevant, while the GPT has assigned it a label of 2, meaning that it's highly relevant. So there's the strong this. However, also when you look at further down to the right, you have where the human has assigned a relevancy score of 2, and the GPT-4 label assigned by GPT is also 2. So there are 30 of those. this is not a great result in terms of accuracy, but what we're using this for is to judging a system to run for ranking. In this graph, we actually show that there is a strong correlation between how the human will judge the result versus the GPT-4 judgment. Each of these blue dots are points that measures a given retrieval method, the way of ranking the results, and the average of all these queries when it's being ranked by this system, and then we evaluate it with either the human judgment or the GPT judgment. And here we can see that if we got a good score from the human on the ranking run, we also get a good score by using the GPT labels. This is quite promising because it also demonstrates that we can actually use this calibrated model to evaluate the results. And once we have that, we can actually start sampling more data. So if we started with the golden set, which is relatively small, we can now start to evaluate more data from production, right? Because we have the calibrated prompt. So now we can actually use that data to get relevancy labels for more data, right? And more data is better because then we are measuring more. So this allows you then to grow this golden set, and this relevancy data set you can use then to tweak your retrieval system, and then you can measure, for example, NT, and you can also use this evaluation to train models and also to kind of use those type of labeled data to further refine and fine tune your retrieval and ranking pipeline. And by doing that, you can then end up where you can, instead of saying that, yeah, we changed something for a retrieval, we can say that, okay, we actually deploy the change that increases NGCD by such and such for this type of queries, right? Because here there's like different retrieval methods, and we have measured how well they're doing by using, ignore what type of method it is, right? Because this will be different for your domain. But the point is that then you can add these different methods or different types of way of doing it, and then you can actually deploy that and actually have, before you actually put it into production, have GPT evaluate the results. So I'm very excited about this. And there's also, of course, now that you can use large language models as a judge, you can also use large language models as rankers, right? So if you have aligned the prompt, you can also use this to, if you can afford it, also allow the large language models to actually rank the documents, right? So first you use the retrieval phase, then also use the large language models to rank the documents, and finally, so answer the question if that's the kind of task that you are building RAG for. So, and the motivation for having these kind of representations in information retrieval, we was talking about sparse representations of queries and text or documents. For example, you might heard of BM25, the traditional keyword scoring that used in popular search engines like Elastic, also in Vespa, is that typically you want to avoid scoring all the documents in your collection, right? So if you have a collection of documents, you can basically do a grep or iterate through all of them, take the query, run some scoring function, sort them by this score, and then you have your top K ranked docs, right? But if you have billions of documents or millions of large documents, this is not very efficient in terms of compute. You can distribute and get latency down, but it's simply not so efficient. So we want to try to have some kind of index that can allows us to kind of add some pre-processing steps. Then we can run the query and do this scoring function, but without having to score every single document. So this is why information retrieval is so focused about building these kind of representations. And one example of representation is, of course, text embedding, where you embed, many of you are familiar with OpenAI, Cohere, etc. Those are typically called dense representations. But there are also sparse representations where you can use like classical data structures that's been around for a long time, like the inverted index. Then you can accelerate the search using this kind of sparse representation using various dynamic pruning algorithms. For example, WAND is one of them, BM1, and there are multiple. Then you have, and these basically are unsupervised, most of them, like BM25 is unsupervised, but it still kind of analyzes your corpus because it builds this TF IDF model of your data. So we kind of know what are the important words, but it's still treating the text as a bag of words. Then you have more advanced methods that are more recent, that is also using neural networks, where you can use supervision, meaning that if you have training data, you can actually learn the importance of the words in the context of the other words. So you use a transformer model for this typically. And there you have supervised representations. Then you have dense representations, vector search, embedding, whatnot. Similar here to accelerate the search. You can build a vector index. There are multiple different algorithms. There are vector databases that are specializing in this with different techniques. Here you can accelerate the search, but you also introduce an error by doing that. You're introducing an approximate. So in order to accelerate, to avoid scoring all the documents, then you will lose some precision, meaning that you might not actually retrieve the relevant result because of this error that you're introducing. And these are mainly using transfer learning, meaning that you're taking an embedding model, you're not fine-tuning it, and you're just using it for your domain. And this is popular, right? So you can, OpenAI, I think OpenAI really made the text embedding retrieval or embedding retrieval like commodity for a lot of developers outside of the information retrieval circles. And you'll represent this in this latent space, in this vector embedding space, and then the score is simply the cosine similarity. Of course, if you have a small amount of vectors, it doesn't really matter what kind of technique you're using. You can use NumPy or whatnot, right? Because brute force searching this data, it doesn't take a lot of time. And there's some challenges with this. So under the hood of text embedding models, most of them are using an encoder-based model like BERT. And each of the input words in the query are represented as a contextualized vector in the output layer. But then since you want to kind of reduce space, you pull this into one vector. So you lose some information by doing this, right? Transforming the input into one vector. You do this for the query and you do this for the document, and you no longer have any kind of attention between the query tokens and the document tokens. You're just looking at the vector representation. And most of these have context length limits, so you need to chunk. And even if they allow you to input a longer text, the longer the text is, obviously because of this pooling step, the vector representation becomes more diluted. And in order to have great representations for retrieval, you need training data, label data. So when you're taking an embedding model off the shelf, like OpenAI, and you're not doing anything with that model for your domain, right? Then that performance of that model heavily depends on what the data it was trained on, because that will determine how well that generalizes to your type of queries, your type of documents. And BM25 is simple algorithm. So research on beer and many other benchmarks shows that BM25, the traditional keyword matching method, has plenty of limitations. It also provides you a very simple out-of-the-box baseline. It's cheap, small. There are also more recent Python-friendly libraries that can do this. But in my experience, it's a very good baseline. There's a lot of different techniques and so forth, but BM25 is actually a pretty solid baseline. It also avoids the fixed vocabularies of transformer models because they cannot learn representations of just if you're adding random words, like a product or a zip code, they haven't learned a good representation of that. So with a traditional keyword search, you avoid these kind of spectacular failure cases. Like broccoli, actually tokenized into multiple tokens like bro. So you might get really weird results sometimes. Yeah, and for a long context, when you basically want to retrieve over maybe documents that are longer, we do see that simple BM25, don't ignore the Colbert stuff for now, but a simple BM25 baseline actually outperforms models that, at least on this benchmark, on actually documents that are quite long, in this case, 2000 tokens. So here actually the simple baseline works much better than models that are quite expensive both to run inference with and also expensive because of the vector storage and also to search this large vector representation. And yeah, of course, if you're using like engines that are capable of combining these into hybrid, you can combine both dense supervised representations and also sparse representations or the BM25 starting point. But hybrid search also, a lot of people mean different things when they talk about hybrid search. It's also not a single silver bullet. But going back to the original talk, if you take the time to do this actually exercise to build your own relevancy data set, then you can actually decide that, hey, I'm just going to stick with B5. That works great for my use case. Or OpenAI is actually a lot better for my use case. Or if I'm adding a hybrid boost here, I'm actually getting better results, right? So that allows you to take these kind of decisions without listening to me or listening to other hypes or DevRels hyping up this model or that model, right? It gives you the confidence and the tool to actually improve retrieval without just listening to whatever people are saying on Twitter or like me saying something. That's the thing I want to, even if, there are multiple different methods. Yes, I'm excited about Colbert. I'm excited about visual representations, Poly and so forth. But having these evaluation data sets allows you to take informed decisions and then finally systematically improving retrieval. And if you see an article like, hey, we do this technique where you rewrite the query using the large language model. Okay, that sounds interesting, right? But you can just plug that into your pipeline then, and then evaluate and see, oh, that actually brings an improvement to my use case. Or no, it doesn't make any sense because it's not improving anything and I'm adding 500 milliseconds of latency and cost to my pipeline. So that's basically what I had.
Thanks for watching. If you liked that video, make sure to like and subscribe. And if you want to learn more, check out improvingrag.com. We're going to talk about the foundations and not frameworks. Over the 6 emails, you're going to learn how to overcome absence blindness, as well as how to fine-tune language models, understanding diverse query types, improving multimodal RAG, and ultimately smart question routing, and build a UX that collects user feedback. Just check out improvingrag.com and fill out this quick email address at the bottom.